All right, guys, had a good coffee break. Everyone's awake. Um, so, if you guys are liking the YYC Data event so far, we have one of the board of directors at YYC Data Society, and he has been active in the Calgary startup and technology community since 2001. Drew also founded the Calgary Artificial Intelligence Meetup in 2017 and has organized more than 30 events, growing the group to over 3,500 plus members. Moreover, right now, Drew is a technology executive, entrepreneur, and a community organizer with over 2 decades of experience. And currently, he leads the Document AI practice within the Google Cloud's incubation team. Um, Now I will give the stage to Drew and let him go ahead and present.
Thank you. He did make up all of that. So. Okay, so I was asked to do a talk, and I thought that one of the things that might be a little different is to talk about the history of OCR and some of the human stories that are involved with it. And until I started researching this, I had no idea actually about a lot of what I learned while I was preparing this talk. So this is where we start. So with Stevie Wonder. So Stevie Wonder, one of the greatest musicians of all time. He was blind actually from birth. So it's pretty remarkable that he was able to write the music that he did. And not only did he write and read music, he read a whole lot of books and magazines and all sorts of whatever he could get his hands on as well. So he was an avid reader. But he wasn't reading it with Braille. He was reading it with a machine that was called the Kurzweil reading machine in his early, this would have been his late teens, early 20s. He became famous at a really young age, and he had the fortune to be able to get his hands on what was the first optical character recognition with text-to-speech machine that had ever been invented. And so in 1976, so Ray Kurzweil invented this device. So this thing required like several fundamental technological innovations, including the first flatbed scanner, including the first synthesizer, to make that possible for Stevie. So Stevie saw it on television, and I suppose he heard it on television. He said, "I want one of those." And he called Ray Kurzweil and he said, "I would like to buy one of your machines." So he was the first person who ever had one of these machines. And that's what it looked like. So it was a fairly large thing, for most people you would need a dedicated room in your house to have that type of thing. But it did really work, right? Whatever Stevie Wonder and other people who used this could fit on the flatbed scanner, they could read. And so Stevie and Ray became friends. Ray actually went on to work for Google, which for a period of time anyways, so there's all sorts of interconnected stories here. But they became friends, and Stevie encouraged Ray to keep using his, he's a genius, this guy, his abilities to improve the world for people with disabilities. But this device and this kind of interaction between these two people wasn't, it didn't just change Stevie Wonder's life. It actually catalyzed a world-changing innovation that has affected all of us. And so how did that work? Fast forward now 20 years later, you're at Stanford, so pretend you're graduate students. So you're trying to solve digital libraries. And so the technology to do that, of course, would be optical character recognition, right? So Google actually began as a library project, which is kind of fitting. I didn't even think about it until now, standing here in the library. But Sergey Brin and Larry Page were trying to figure out how to, make the world's information more universally accessible and useful. And at that time, it was all about scholarly papers and articles and books. And so they wanted to use the citation analysis method that has been used in scientific research forever, but apply it to books and eventually web pages. And so the mission of the Stanford Digital Library Project was to develop the enabling technologies for a single, integrated, and universal digital library. And so that's the core technology behind Google, actually. So although Google didn't start, Google Books came afterwards. So this was 1996. The technology, as Page and Brin realized, was far more valuable for the web than it was for books. They still came back to it. So they imagined a future where every book in the world could be read by anyone, anywhere, at any time. Even if they were blind, and especially if they were blind and didn't have a spare room for their Kurzweil reading machine, right? So you get all that content online, and that makes it a little easier and more accessible, right? And so in 2004, so this would have been 8 years after the founding of Google, they one day said, hey, we should get back to that. They put together this hardware and they started scanning books. So it was the fundamental research to improve OCR, which had been pioneered by Ray Kurzweil, that enabled Google to digitize those books. And that technology, of course, most of us are familiar with it. You can use it to recognize text from images, like menus, right? These days, I think a lot of us might be doing that, street signs or documents. And that's what I'll talk a lot about today. So Google Books used OCR techniques that were super advanced for the time, a lot more advanced than what Ray Kurzweil had done, to extract images from handwritten, faded, older books in 400 languages. So it's pretty remarkable. So 40 million books have been scanned, covering more than 400 languages. Oops, we lost a slide there. So pop quiz. I want to make sure that we don't fall asleep. I know this is at the end of the day. What's the name of this data set here on the right-hand side? Anyone know? Yeah, it's a pretty big, pretty popular data set, right? So optical character recognition, of course, started with data sets like this, which the data set we use today has been augmented in many ways just to make it more robust and to give it more samples. But like this was the data set, right? In many ways, it was very foundational. So Google Books became an unprecedented resource for researchers, students, teachers, readers, writers, anybody who loves books. So what does this have to do with document AI, and what does it have to do with us today? So we now have information that we can, we have access to technology that can transform images into text, and text into data, and then data into knowledge, and ultimately knowledge into action, right? That's what we're all hoping for. So it's not just about understanding characters anymore. It's about really understanding meaning. It's not extracting the text. It's like figuring out what are we going to do with this thing to create business value, or to not spend so much of our time on it, right? So one more exercise for you. So imagine you're this guy. He's very good looking, I think, anyways. He's solving a crime, and now you are detectives trying to figure out the crime as well. So there's all this evidence. There's like bullet casings and blood and all that sort of stuff. And you're analyzing it to figure out who committed the crime and why. But you're probably going to miss some evidence. And what if those hidden pieces of evidence were overlooked or ignored? It could change your whole understanding of the case, right? And as I'm sure many of you know, that's what happens in business all the time. Every business out there has a lot of data, sales records, customer feedback, web analytics, and hopefully most of them these days use it to improve performance, we would hope. But like almost certainly there's tons and tons and tons of it still being missed, and particularly just some of the connections that might be non-obvious. And they're sitting in like this stuff, right? So much like there's lots of articles about dark data, and there's other terms for it, but most, like honestly, the volumes of data that aren't realizing business value, they're not dark at all. Like they're white because it's paper, right? So so that is what we'll talk about for the rest of the talk. So getting paper off data faster can help business reduce risk and be more efficient, be more innovative, and create competitive advantage. So with Google Cloud's Document AI portfolio, and that is a portfolio that I support and am responsible for. So I support our global practice. I am a global practice lead for Document AI, and so our regions around the world, if they were to have a use case, that included the technology that I'm going to talk about, they would call on my team to help make sure that they get the most out of it. So what is it? We realized that what our customers really want is structured business-ready data from their documents, right? So if you think of all the PDFs, emails, invoices, forms, contracts that you may interact with, there's a ton of data locked up in these files, and I'm sure all of us could come up with more examples. Like, I don't know, an intake form for a medical office is a very common use case. I think I was just outside complaining that I filled one out online and then was asked to fill it out by hand when I got there as well. And I was like, why? Yeah, so the OCR only solves half of it. Like, we need to get actually the structure and the understanding if we ever hope to extract information out of something like that those intake forms, because they're pretty complicated, right? If you were to OCR it, you're just going to get a stream of meaningless text. And then that's kind of part of the problem and what has made this a bit hard to crack, because anybody who's tried to solve this, including myself in operating an e-commerce business in the past in my career, we would have a difficult time doing reconciliation on the purchase orders and packing slips and invoices for all the product that we'd receive. There's so much variation, and I said to myself so many times, there's got to be a better way. But by the time you figure it out, some new some new invoice comes along, breaks your model, and you're like, just do it by hand, right? So businesses want the technology that will read documents like us, and they want the confidence, and this is the important part, to know that when they start automating manual processes, that they're not signing up for like a different kind of digital manual work, because I think most of us probably understand that semi-automated solution it could even be worse, right? So we wanted to remove as much of this data entry toil and validation as we could, and reduce the document processing time for companies in any vertical, in any industry. And that can be super valuable when you're processing, some of our customers would, to this day, process hundreds of thousands to millions of documents a month, right? If you're working with mortgage document packages, like each document package is huge, and it just adds up, and it's all paper still. So let's talk about the categories of document AI, and then we'll get a little bit into the different pieces of it. So where it all began is with OCR on the left. So that'll work with just about anything that you can throw at it, but again, it's not going to give you the structure. There is a form parser in our portfolio, which is able to get key value pairs off of a form and give them to you in a way that you can then immediately interact with. And we do document quality analysis at every step here, but you're able to essentially see a lot of different metrics about what, garbage in is garbage out, right? And so a lot of people have unrealistic expectations, but we can sort of score what the input is and give you a sense for how likely it is that you would actually be able to parse it, right? The form parser, as I said, it's just in the last year, we can now see a form just like a human would and get every question and answer off that form. In the middle, the Doc AI Workbench, that's a solution that allows you to train like fully custom processors, and those are based on your own documents. And then Human in the Loop is a set of features that just make sure that anytime you do this, you need to make sure somebody's in the loop to just validate that it is still working the way that you expect, and to just have eyes on your process. So Human in the Loop is both for training and then for workflows, which I'll get into later on. And then once you get your output, that's when you can really start to make it useful. So everybody here probably has their own understanding of what those use cases look like, but like analytics on written customer feedback, which again, that happens more often than we think these days. Multi-page application forms, super common, or just maybe getting more visibility into procurement. And then you can do that, as an example, by landing that extracted data into something we call Doc AI Warehouse, which I'll talk about again in a little while. It's just a platform for storing and searching and managing lots of documents at scale. And what's interesting about it is that it kind of actually makes a lot of our data processing pipelines that we've built over the last 20 years a little bit. You've got to wonder, if we were able to return to paper as an interface and it was to actually work, how much would that change? And the answer is actually quite a lot, because you don't need to necessarily have like an analytic workflow to put all of the data on your paper into. You can actually just keep it on paper and make a copy of it in this thing that we call Doc AI Warehouse, and work actually directly on those documents, which some of our customers are starting to do, which dramatically simplifies things. So you can think of this whole portfolio, it's just a unified suite to understand and organize documents. And this diagram, this is available online. I'll only spend a couple seconds here, but these are all the components, and just sort of a quick journey as you kind of think about your own use case and consider which components might be able to help with it. So from a fundamental OCR quality perspective, the OCR technology that's behind this, that again was invented for Google Books and has continued to improve. It's industry leading, so even handwriting, 200 languages, and the form parser, as I was saying earlier, extracts checkboxes, tables, key value pairs, and also in over 200 languages. So if you have something that's a little bit more structured or specialized, the portfolio has pre-trained general and specialized parsers for things like invoices, which we've talked a lot about, receipts, procurement document, like any procurement documents, lending documents, like I was mentioning earlier. And so, but if that's not enough, so we will build and maintain those models, but so that you don't have to, but almost always there'll be one or two things that you might want to do. And so you can use this platform to train models on your own from either scratch or by fine-tuning one of our base models to give you exactly what you need, and without writing any machine learning code. So that's all, it's no code. It's not low code, it's no code. And so we call that uptraining. So uptraining is, there's various words that we use. Transfer learning, is a synonymous term. But basically, if you had, say, an invoice that, say you operated a vet and you wanted to put the pet's name on the invoice to personalize those invoices, that would be an example of a very quick uptraining operation. You put some of your invoices in, you draw a bounding box on that pet's name, and after just a few examples, sometimes as few as 10, more realistically 25 to 50, but that's not very many when you're trying to do this stuff. We can then pick that information off, or I should say you can then pick that information off and get it in the object that comes out of it. So the part of the portfolio that does that, it was in the middle of the slide a few slides ago. We call it Workbench. So this includes classifiers, splitters, and extractors. So if you were to, say, scan 1,000 pages of heterogeneous documents, we could split, and it depends on how dissimilar, of course, but with pretty good accuracy, we could split that package and then figure out what to do with it, which is again, just a very common workflow. I don't know how many of us here work with large document packages on a regular basis, but this is a game changer. It saves a lot of time. And you don't have to be an expert to do any of this. It's pretty accessible. So this Workbench product helps you train custom document extraction models. And I think I gave the veterinary example, so I'm going to just skip through my notes here for a second. Let's talk about totally unique documents. So if you are starting entirely from scratch, what you would need is a labeled data set of documents, of course. And so what does that mean specifically? It means that somebody spends some time, drawing regions of interest on those documents, and then that labeling process will be used to to train and evaluate a model. So because I do work for Google, and today I am speaking personally. I'm not speaking on behalf of Google. There's only so much that I can say about the way that this technology is changing, but what I can say is that just in the last 6 months, as we've seen, anybody who's paying attention, there's a lot of really exciting innovation in the space. This already works really well, but with the multimodal large language model improvements that are coming, it may be possible that you would not have to train anything at all, actually. And so again, I'm definitely not speaking for Google today when I say that, but it's pretty exciting stuff. So if the model evaluation looks good, you click a button to deploy that process. We call it a processor endpoint. And then how do those evaluation metrics get generated? It's just by comparing the prediction values, of course, to the ground truth annotations that you've made. So I expect this value to be in this part of the document. One of the coolest parts about it, again, assuming that everything doesn't change here very quickly with the multimodal large language models, is that after you run just a few training operations with, say, between 10 and 50 documents, you can continue to train on similar documents without having to label. And the reason is we can use the predictions for where the labels should be on the incoming set of training documents, and it usually gets you very, very close. So the initial training process makes it possible to predict the bounding boxes in future training sets, and then that makes it really just quick and easy to just kind of get, say, if you were at a document accuracy of 90%, if you wanted to get higher, you sometimes just need to show it more examples. I think many of us are probably familiar with that machine learning workflow, and if you're not, we can talk about that afterwards. Regardless though, like nobody wants to sit there and label stuff for an entire day or more. So we make it really easy to crowdsource this. So you can use your own workforce, you can use our workforce, but basically we just allow you to parcel out the work to validate that the predictions are in fact match ground truth, and then that all gets fed back into the system. And ultimately you just want to make sure that the output has been verified before you use it in your business applications. And so this is one of the smartest ways to do that. So then document warehouse, I had mentioned it earlier, but this is one of the most significant innovations, I think, in this space. If you have millions or even billions of documents, one of our customers has 5 or 6 billion documents in this platform, you need a way to extract insights from them, search for them, manage access and compliance. This is a really tricky problem, right? And historically solved, right? I mean, IBM FileNet has been around for a long time, and there's lots of competitive alternatives, but one of the things that they don't do is that full text semantic search very quickly, and they also don't shred your schema automatically and index it, right? And so by shred, I mean it's taking the schema that you expect and putting it in the open source world, or I suppose not quite open source, but like Elasticsearch would be a product that would be somewhat equivalent, but this is an internal Google product. And so it allows you, so once your documents are in there, you don't need to have like a separate analytical store. So, and this was the point that I made earlier, I'm not sure if I made it too clearly, but many times a company wants their source of truth and their documents to be separate. And we think that doesn't have to be the case. You can actually put them together and you can store them in the same place and consider the piece of paper the interface and the source of truth, because it actually is, right? You're going to be returning to the paper anyways. So when you're dealing with a large amount of documents, we have 4 things that we think any system like this needs to do well. I've talked about automatically extracting and storing data, covered that. Making it easy to search for documents, like easy meaning like instantaneous, right? We shouldn't be hunting for things in filing cabinets or otherwise, or waiting for our incumbent, like our legacy systems to return results. Governance and compliance is super important here. Access control and auditability for this stuff is critical. But the workflow integrations, I think, is the most important part, because every business is going to run document workflows a little differently, and so you need something that you can build on to do, exactly what you want to do and integrate it into your own line of business applications. So I've kind of been jumping around in my notes. I apologize, but I think I've made most of the points I wanted to make. I have a note here just to really hammer home that this paper as an interface concept is what I find really exciting. I was speaking outside to somebody and talking about ebook sales and traditional book sales, and even though the reading experience on the new Kindles or whatever, like, it's pretty good, like, it's still, ebooks haven't killed traditional books yet, and I don't think they will. And I think as a human, like, I work for Google. I have my notes on paper. I always will. I write my notes by hand, and I always will. How neat would it be if we were to have this AI technology actually empower us to do what's natural? Like, we've been using paper for 2,000, 3,000 years, right? So it actually works. Like, let's make, instead of using these horrible interfaces where you're trying to get through a multi-step digital form and you're like, which field does that asterisk correspond to, right? And then of course you have to do a lot of validation throughout that, because you're going to have input errors, but like, that's just the reality. Like, humans are 97 or 98% accurate. That's human accuracy when they're doing transcription. So what a lot of people don't think about is that when we get a machine to be close to human or better, that it can save time for that person to just do something more valuable, right? Here's sort of probably the most technical slide in the deck, and then I'm almost done here, but this just sort of emphasizes the possibilities. So, like, you can build with this platform fully end-to-end document workflow with policies and actions. And so in this case, the example on the screen is like, let's search that document warehouse for all of the documents that match some specific criteria. So in this case, it's like all invoices over a certain amount, maybe payable within a certain number of days, maybe in a specific case to a certain supplier. And we can then find those documents, find those actual invoices that at the end of the day, like, if your finance team is going to pay something, like, they want the invoice. They don't want the record that corresponds to the invoice. And then they pay it, right? Another good use case for warehouse is for records management. If you have documents that you need to dispose of after a certain period of time based on legal hold retention periods, then you can do the same thing by defining a policy that then deletes the documents when they're supposed to be deleted, or the opposite. So put a lock on any changes to something that's in the system at all for a period of time. So the possibilities here are pretty endless. Like, for anybody who's spent any time working with these types of document processing workflows, whether trying to automate it or maybe part of it as somebody involved, like changing how we do this, there's a huge opportunity. The possibilities of just changing the way people work are exciting. So we started talking about Stevie Wonder, and I think it's pretty cool that his enthusiasm for reading and the Kurzweil reading machine paved the way to digitize books and then develop this OCR technology that is world-class and continues to improve. And that led to this wonderful digital library. I think it's the biggest digital library in the world, right? 40 million books. And then, it didn't stop there, though. This OCR technology had to improve to actually understanding what we're looking at. And what we want is that business-ready structured data, which actually can realize tons of business value. And so you can put billions and billions of documents into systems like this, and using that industry-leading OCR, and in the future, very near future, multimodal large language models. That's a total game changer. So Stevie Wonder's passion for reading led to the development of groundbreaking technology that transformed the way we access information. And I think that document AI is poised to revolutionize the way that we process and extract value from our documents, and hopefully transform people's lives at work. Thanks. take some questions if anyone has them.
Sorry, we don't have time for questions.
Oh, I was right on time. There you go. Perfect. Yeah.
But